Oh, hey guys, Kelly Barrett here, and I am just listening to some music. That was Justin Timberlake. It's supposed to be the song of the summer. So speaking of music, we have a great problem here. It's my musical problem that I found. So I'm going to read the whole problem, and then we're going to break it down into part A, part B, and part C. So here's the background. Joe's iPod has 500 different songs consisting of 50 albums and 10 songs each. He listens to 11 random songs on his iPad, with all songs equally likely and chosen independently, so repetitions may occur. So that's the background. The questions that follow is, first of all, what is the PMF of how many of the 11 songs are from his favorite album? So the probability mass function is what we're looking for there. And with that, we're going to have to talk about the distribution and everything like that. Part B says, what's the probability that there are 2 or more songs from the same album among the 11 songs he listens to? Do not simplify. And part C says, a pair of songs is a match if they are from the same album. If, say, the first, third, and 7th songs are all from the same album, this counts as 3 matches. Among the 11 songs he listens to, how many matches are there on average? Simplify. So some tough questions there. We're going to go piece by piece. Let's get started. So the first part of this is asking what the PMF of how many of the 11 songs are from his favorite album. So PMF stands for probability mass function. And in order to correctly write your probability mass function, we need to understand what the distribution of the situation is. So I thought about this for a while, and I came to the conclusion that this could be a binomial distribution. So this is binomial because if we think about getting the song from the favorite album as a success, then getting a song that's not from his album is going to be a failure. So that's why it's going to be a binomial distribution. So I'm going to first write down what the formula is for a binomial PMF, and then we're going to go from there. So now here we have some information about the PMF for a binomial distribution. First of all, the parameters for binomial distributions are n and p. Okay. Here, our n in this situation is going to be 11 because we're choosing 11 songs randomly. And then we have to talk about the probability that we get a song that's from his favorite album, okay? So that's going to be the success, is that we get a song that's from the favorite album. Well, there's 50 albums, okay, and only one of those is his favorite. So it's 1 out of 50 for the probability that the song you get is from the favorite album. Now, the formula for a probability mass function for a binomial distribution is right here. Okay, so it's n choose k times p to the k times q to the n minus k for k from 0 to n. So that means k is going to be our variable, and we're going to plug in everything else that we know. This will give us a PMF of 11 choose k, because again, there's 11 random songs that we're playing, that we're choosing from, okay? And then we have p is 1/50th to the k. And then the q, obviously, is the probability of a failure, which is going to be all 49 other albums. So that's going to be 49 over 50, okay? To the n minus k, again, n is 11, so 11 minus k. Okay, and this is going to be, for this situation, k is just going to be between 0 and 11. So from 0 to 11. And this right here, ladies and gentlemen, is my PMF. There she is. Let's go on to part B. So the next part is saying, what is the probability that there are 2 or more songs from the same album among the 11 songs that he listens to? Okay, so we are trying to find the probability that we have at least one match. Match meaning, like the next problem specifies, that 2 songs are from the same album. So at least one match. Okay, finding the probability of at least something, as at least anything, we can actually rewrite doing 1 minus, this is the complement, the probability that there are no matches. Okay, it's easier to find the probability that there's no matches, so that's why we're going to actually end up using this. 1 minus the probability that we have no matches. So for the probability that there's no matches, I'm going to go old school here. And I'm going to think about this, kind of thinking about like the slot method. So let's go ahead and draw a fraction. Okay, and so in the denominator, we have 11 songs that are going to be picked randomly, and the chance of getting from a specific album, there's 50 albums, right? So on the bottom, it's going to be 50 times 50 times 50, because it could be from the same album. So there's 11 songs that are happening, and every single time, there's 50 different albums that the song can come from, okay? So I'm going to actually erase this, and we are going to write the total as 50 raised to the 11th. Now, numerator is going to be a little different, okay? Because for no matches, right, the first option is 50 different albums that the song could come from, right? But for the second one, for no matches, it means that there's 1 less album, okay, to come from. And then this is going to go on for 11 total songs, which will bring us down to 40. That's the probability that there's no matches. So let's simplify this a little bit. It says do not simplify, but we're going to write this in a little bit of a different way, and we'll move on. Just to clean it up. So this 50 will cancel with one of these 50s. So that's going to be to the 10th. And then, okay, we could think about this as, what if we rewrite the numerator as 49 factorial? Crazy, that's going to go all the way down to 1. But we don't want it to go down to 1. We want it to go down to 40, which means if I put 39 factorial in the denominator, then from 39 down to 1, numerator, denominator, those will cancel. So here is a different way to write the probability that I have no matches. And that means that the probability that I have at least one match is going to be 1 minus this probability right here. So 49 factorial over 39 factorial times 50 to the 10th. And I will not simplify that. But that is the probability that I will have at least one match. Let's move on to the last part. So this last part's kind of fun. We can use our PMF to help us with this, so it's kind of coming full circle. A pair of songs is a match if they are from the same album. So say first, third, and seventh songs are all from the same album. That's 3 matches. Okay, so among the 11 songs he listens to, how many matches are there on average? This is looking for an expected value. So the first thing we want to do is kind of define like an indicator kind of random variable. So let's just say this is our indicator. So that's our random variable right there, and this is going to be for the event that the jth and kth songs match. So that's our random variable. So we're looking for the expected value that this happens, which is going to be the probability that there's exactly one match, right? So the probability that this happens one time, which is something we already talked about, okay? The probability that we have one match or one success is 1 out of 50. 50 albums, okay? One album out of 50. So let's finish this out, okay? So for this now, we are going to be choosing 2 songs, okay, out of the 11 that we're listening to. Okay, and we have the probability that I get the jth and kth songs matching, which is going to be 1 out of 50. We're not looking for a probability. Okay, so we don't have to multiply by the Q number in our PMF. We just can stop here. We're just looking for the expected value. So we have 11 times 10, okay, over 2 times 50. When we do that, we get 110 out of 100. Let me double check my math on that. Should be 1.1. You could also just type this into your calculator, and you do in fact get the same thing. So among the 11 songs, how many matches are there on average? Close to just 1. So that's that. Okay, so let's close this out and talk about what did we learn. For me, I think that the biggest thing is being able to read and understand a word problem, and especially figuring out the distribution. Okay, and then taking that and being able to write a PMF or a PDF sometimes, if it's continuous. And then it depends on what the follow-up questions are. We didn't really use our PMF to answer some follow-up questions. That's taking the probability mass function and then finding probability. This particular example was asking questions based on the given information, but again, answering follow-up questions. And for us, we talked a lot in class about the binomial distribution, so I thought it was going to be useful to talk specifically about the binomial distribution. So that's what we learned today. I hope that this was useful. And thank you for a great quarter. We'll see you soon.